Okay, so welcome back. In this example, we have another integral to work out. This time we have the integral of t squared, square root of 4 minus t squared. So once again, we recognize here we're dealing with an integral of the form a squared minus x squared. Right, so there are three types of trig substitutions involving a squared minus x squared. We use the sign substitution. If it's a squared plus x squared, we use the tangent x substitution. And if it's x squared minus a squared, we use the secant substitution. Okay. So here we're dealing with another a squared minus x squared, or in this case, a squared minus t squared. But we know we're once again dealing with a sign substitution. That's the first thing we want to recognize. We're here a is equal to 2. Okay, so we use the substitution. T equals 2 sine theta. And then we differentiate. dt equals the derivative of 2 sine theta, which will be 2 cosine theta d theta. Okay. So let's make those adjustments and see where that leads us. So t is being replaced by 2 sine theta. So first of all, dt, I'll deal with the 2 cosine theta d theta in a minute. But first, t is being replaced by 2 sine of theta. So this is going to be 2 sine theta squared. And then we're going to have square root of 4 minus 4 sine squared. We're replacing t with 2 sine theta, so when you square it, it'll be 4 sine squared. And then that's all times dt, which is, in this case, 2 cosine theta d theta. Okay, so let's see what we're going to have here. So once again, we have a 4 minus 4 sine squared, which would eventually become 4 times 1 minus sine squared. But 1 minus sine squared will become cosine squared, and then we apply square root. So what we're going to end up getting is this integral of 1 over. So this is going to be 4 sine squared of theta. And then this is all going to become just 2 cosine theta, which fortunately will cancel with the other 2 cosine theta. Okay, and that's because, again, 1 minus sine squared will become cosine squared. 4 cosine squared inside square root will be 2 cosine. 2 cosine. Okay, and then we can cancel out. Again, that 2 cosine theta goes away with that 2 cosine theta. So at this point, we have 1/4 the integral of 1 over sine squared d theta, but we recognize 1 over sine squared is just another name for cosecant squared. And cosecant squared is one of those ones that we know the antiderivative of. So this will be negative 1/4 cotangent theta plus a constant. Okay, and then we're ready to do the work to convert from theta back to t. From theta back to t. And so what do we know? We know that t is equal to 2 sine theta. So that means, of course, that sine theta is t over 2. So we can go to the picture now. drawing this triangle where sine theta is t over 2. Remember, sine is opposite over hypotenuse. So we use Pythagorean theorem to find the third side, which would be square root of 2 squared minus t squared. And now that we have a triangle, we can compute cotangent of theta. Cotangent of theta. Tangent, remember, is opposite over adjacent, so cotangent will be the reciprocal of that. So in the end here, we get negative 1/4 times square root of 4 minus t squared, all of that over t. And so there's our final result there. Negative 1/4 the square root of 4 minus t squared all over t, and then of course plus a constant. So this was one that worked out kind of neatly because our cosine part disappeared and we were left with sine parts in the bottom, but we were able to turn those directly into cosecants, which made this an easy integral. And then we again draw our triangle and use it to compute, in this case, the cotangent of theta.